Hello students, welcome to my physics class. Now today I'll start interference of light. Now what is interference of light? This is basically superposition of waves. Now the term interference refers to a phenomenon involving superposition of waves leading to modification of their intensity in the region of superposition. Now let's consider superposition of two waves. Here we are considering y1 and y2. So y1 equal to a1 sine omega t and y2 equal to a2 sine omega t plus phi. Now the resultant wave will be combining these two, addition of these two waves y1 and y2. So it will give a1 sine omega t plus a2 sine omega t plus phi. Now here please remember this phi is the phase difference, constant phase difference between y1 and y2. Now if I break this a2 sine omega t plus phi, then it will be a2 sine omega t cos phi plus a2 cos omega t sine phi. Okay. Now if I combine the sine omega t term and cos omega t term separately, so basically it will be a1 plus a2 cos phi sine omega t and plus a2 sine phi cos omega t. Now let's say a1 plus a2 cos phi is a cos delta and a2 sine phi equal to a sine delta. So this capital A is the resultant wave which will be coming out root over a1 square plus a2 square plus 2 a1 a2 cos phi, and this delta is the resultant phase if I tell. So that will be tan inverse a2 sine phi divided by a1 plus a2 cos phi. Okay, so ultimately we are getting y equal to, that is the resultant wave, displacement or amplitude. So the amplitude will be here a and y1 is the displacement. So y equal to a sine omega t plus delta. Okay, now this cos phi value can be plus 1, 0, minus 1. Okay, so if it is plus 1, so we are getting resultant intensity as a1 plus a2 whole square, and this is basically the constructive interference is happening here. And if cos phi equal to minus 1, then a1 minus a2 whole square destructive, that represents the destructive interference. Now cos phi equal to plus 1, when constructive interference is happening, the phi is actually 2n pi. The phase difference is 2n pi. So n can be 0, 1, 2 like that. So 0, then 2 pi, then 4 pi, like that, all even numbers. And for destructive interference, you can see phi equal to 2n plus 1 pi. So if n equal to 0, or odd terms will be considered. Okay. Now let's understand the intensity distribution pattern, and from there conservation of energy. So this resultant intensity we are getting I equal to a1 square plus a2 square plus 2 a1 a2 cos phi. Okay. Now if I plot it, the pattern will be looking like this. So the maximum intensity is actually a1 plus a2 whole square, and the minimum intensity is a1 minus a2 whole square. So you can see in the phi equal to all even numbers, basically 2 pi, 4 pi, we are getting the peaks, and in odd terms like pi, 3 pi, the intensity is basically the low. Okay, so now the average intensity we can find out like this. So I average is 0 to 2 pi I d phi divided by 0 to 2 pi d phi. So basically we are considering in one full cycle from 0 to 2 pi. In a wave, you know, the full cycle is from 0 to 2 pi. This is basically from 0 to lambda wavelength. So if I put the form of intensity here, I1 plus I2 2 root over I1 I2 cos phi, then after integrating it will be I1 plus I2, because if we integrate over cos phi it will be minus sine phi. So sine phi 0 to 2 pi is 0, so that's why that term is not here. So basically the average intensity is obtained as I1 plus I2, right? So that means overall intensity remains constant. So in the region of constructive interference, which is the bright band, energy is high, and in the region of destructive interference, the dark band, the energy is low. So thus the energy is basically redistributed in different bands. So overall energy remains constant. Okay. So this is the conservation of energy. Thank you.